Affordable robots, from ocean depths to everyday helpers. This episode explores 62 papers in computer science robotics from November 10th, 2025. Innovations making robots accessible and intelligent are examined, synthesized from recent uploads to the arXiv preprint server in Robotics. Presentation overview, diving into robotics breakthroughs. A journey through 62 robotics papers from November 10th to 11th, 2025 is undertaken. Themes, findings, and future paths are uncovered in an engaging story. It is presented like chatting with a friend about robots reshaping the world. Affordable fleets, smart controls, and safe humanoids are highlighted. Curiosity about AI's embodied future is aimed to be sparked. Field overview. Understanding computer science robotics. Computer science is blended with physical machines for intelligent robots. Focus is placed on sensing, decision-making, and action in real environments. Key elements include AI algorithms, sensors like cameras, and precise control. Challenges such as the sim-to-real gap are addressed for reliable deployment. Impacts on healthcare, exploration, and daily tasks are achieved with safer efficiency. Research Theme 1, Multi-Agent Collaboration, Coordinating Robot Teams. A key theme involves robots working together without central control. Durrant et al. Enable low-cost underwater fleets using acoustic signals. Gupta et al. Prevent deadlocks in multi-robot navigation, like virtual traffic. Affordable exploration in oceans or disaster zones is supported. This overlaps with learning for robust team dynamics. Research Theme 2, Motion Planning and Control. Navigating complex spaces. Focus is placed on efficient paths in dynamic environments like stores or terrain. Cheng et al. Achieve sub-second dual-arm planning with overlapping kinematics. Ham et al. Use dual MPC for quadruped stability on uneven ground. The technical concept of model predictive control optimizes future actions conversationally. Computational load is reduced for real-time robot decisions. Research Theme 3, Safety and Robustness, Handling Uncertainty and Falls. Safe operations in unpredictable real-world settings are emphasized. Jia et al. Adapt barriers for out-of-distribution data in vehicles. Xu et al. Unify fall prevention, mitigation, and recovery for humanoids. Research Theme 3, Safety and Robustness, continued. Building resilient systems. Inspiration is drawn from human reflexes for robot reliability. The technical concept of reinforcement learning adapts from trials without labels. Robustness is ensured, bridging sim-to-real gaps for deployment. Connections are made to multi-agent and planning for overall adaptive robotics. Key findings, critical insights from the papers. Durrant et al. Democratize underwater mapping with $3,000 cooperative bots. Cheng et al. Achieve 99.9% success in fast dual-arm grocery tasks. Jia et al. Enable brain-controlled extra limbs after short training. Luo et al. Boost humanoid control by 16% with massive motion data. Xu et al. Reduce fall impacts via unified safety policies. Methodology, synthesizing common techniques. Model predictive control optimizes paths with constraints, but it is compute-heavy. Reinforcement learning enables adaptation from data, with risks of sim-to-real fails. Sensor fusion combines vision and sound for robust perception in noise. Graph-based planning scales multi-agent navigation, needing dynamic updates. Methods often blend for synergy in complex robotics challenges. Selected Research Paper 1, Low-Cost Multi-Agent Fleet for Acoustic Cooperative Localization Research, Durrant et al., 2025. This paper is selected for impact in affordable multi-agent systems. Novelty lies in customizable underwater bots under $3,000 that democratize research. It represents key directions in cooperative localization for exploration. Justification comes from real-world trials, reducing costs and sensor needs. Accessibility gaps in robotics innovation are bridged. Selected Research Paper 2, Sonic, Supersizing motion tracking for natural humanoid whole body control. Luo et al. 2025. This paper is chosen for novelty in scaled learning for humanoids. Impact includes a 16% benchmark boost from massive datasets. It exemplifies learning-based approaches for natural movements. Justification is provided by enabling generalist robots without manual tuning. Efficient, transferable embodied AI is pushed forward. Selected Research Paper 3, Unified Humanoid Fall Safety Policy from a Few Demonstrations, Xu et al. 2025. This paper is selected for representativeness in safety integration. Novelty involves combining prevention, mitigation, and recovery from sparse demos. High impact on resilient humanoids for real-world use is achieved. Justification stems from robust sim-to-real transfer and force reduction. Human-centric robotics directions are advanced. Future directions, next steps in robotics research. Bio-inspired designs like musculoskeletal simulations, Zhu et al. Are advanced. Sim-to-real gaps are tackled with cross-domain learning. Ethical frameworks for brain interfaces and autonomy are developed. Energy-efficient swarms for edge environments are focused on. Sustainable materials for broader deployment are innovated. AI synthesis and review. How this deck was created. Synthesis is performed using AI tools. GPT Grok using model Grok 4.0709 for content generation. TTS synthesis is conducted using OpenAI for audio narration. Image generation is handled using Google for visual elements. Review is undergone by a human expert. Note: some oversights may exist. All references are provided for verification. Subscribe and channel info. Stay updated with AI frontiers. Subscription to the YouTube channel for more robotics insights is encouraged. The title is AI Frontiers. The description is provided. Joining to explore cutting-edge AI and robotics narratives is invited. Hit subscribe and turn on notifications today. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv, from neural networks to quantum computing. We simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.